Okay, let's look at this one. All right,
Yeah, that's definitely like
what are we doing here?
8,000 RPM.
Find the domain.
Find the domain, there you go.
And domain.
All reals, right?
Yeah.
Okay, there's no problem here, we've got an odd root, right? Everybody get that?
Yeah.
It's an odd root, so there's no issue there, this term is fine, so domain's all reals. Okay? Yes.
Take the derivative.
Take the derivative, let's take the derivative. What's this term going to give us?
2 x and negative
Okay, good, by the power rule.
1 minus
Don't tell us the trade. Oh, is it here?
Okay? All right, let's go ahead and do some stuff with that, so then,
2.
what can I do with that?
Take out a 2.
Okay, I could take out a 2,
And
good.
x.
And I'm gonna go ahead and rewrite this once too, I'm gonna rewrite this with a positive exponent. Okay, so we can see things better. So that's gonna be 2 over cube root of x, right? Minus 2x. Okay? And then, well, you talk to me about that. So we gotta find critical numbers, right? Okay.
So is that equal to 0?
Okay, so one thing I can do is set it equal to 0. So,
But you also can't divide by 0.
right. Okay. So if I factor a 2 out, I'm left with x to the minus 1/3 minus x. Right? So then when is f prime equal to 0? Okay, good. When x to the minus 1/3 minus x equals 0. So wouldn't that just be then when x equals 1 over x to the 1/3? Okay.
Then you can times it.
So how would I solve that, please?
Multiply both sides by x to the 5.
Okay, cross multiply either way. That's gonna give us x to the 4/3 equals 0. Oops, hang on, equals 1, sorry, 1. Right.
And then you're going to take the, or back to 1/4 minus cube.
Okay, yeah, so now, here's an issue we gotta think about. So, how do I undo x to the 4/3? One, not multiply by, I'm gonna take both sides to the 3/4.
Yeah.
Okay, so am I taking an even or an odd root then?
Even.
It's an even root, so what do I have to do if I take an even root of both sides?
The absolute value.
Okay, right, and the shortcut would just be I need a plus or minus, right?
Yep.
Everybody get that? If I take it in 2 steps, it's easier to see. I could start off by cubing both sides. And that's gonna give me x to the 4th equals 1. And then I would have to take a 4th root, but let's do it in terms of 2 successive square roots, okay? So if I square root both sides, what's the square root of x to the 4th?
X squared.
Okay, so that's gonna give me an x squared equals plus or minus the square root of 1, right? And then I could square root it again. And what am I gonna get?
You still get plus or minus 1 and 2 imaginary.
Okay, good, so I'm gonna get x equals plus or minus, I got 2 different answers here, right? I get plus or minus the square root of 1, or x equals plus or minus the square root of negative 1, so plus or minus I. Actually, I'd end up with, yeah, plus or minus I, okay. We don't care about those, obviously,
No.
right? Okay, but why do we, I just wanted to show you one thing here. Why did I do that?
Because if you just do the
Good, if I just directly take a fourth root, you see here that I'm only getting the real zeros. I just want to make that point to you, okay? The other way we could do that one, and I'm just gonna, this is just some filling, just a little bit of review, pre-calc review, but this is pretty good review. So if I had, what was it, x to the fourth equals 1, okay, I could rewrite that as x to the fourth minus 1 equals 0, and I could factor this. Okay, what pattern does that follow?
X
Ah.
plus 1 plus X squared. or
Okay, good,
minus
yeah,
X
I could
squared.
write this as different squares, couldn't I? I could write this as x squared squared minus 1 squared, which would factor into x squared minus 1
Oh, but-
times x squared plus 1, right? And now if I solve both of those, if I set them equal to 0 and solve using the zero product property, this is gonna give me x squared equals 1, so x equals plus or minus 1. This gives me x squared equals negative 1, so x equals plus or minus I. Right?
Let me goose it over
What do we do?
there. The X squared minus 1 squared, I've never seen it before.
Well, that's just to make it clear that you can do the difference.
Yeah, so I just have, a squared minus b squared.
Yeah.
See what I'm saying?
Yeah.
It's just a difference. So all I'm saying, I get what you're saying, but it's, I'm just following this pattern.
Typically, we don't write it out, we just acknowledge that it's there and
Oh.
do it. But he wrote it out.
Yeah.
Right.
Yeah.
See what I'm
Yeah.
saying?
Yeah.
So, so I'm just
Oh,
showing you
okay,
that
I
I've got
see.
a
Okay.
difference of squares.
Come on, man.
Yeah, you don't
I
need to
see.
put it there. Yeah, I just put it there.
Obviously.
Okay, so then I get zeros at plus or minus 1. Those are places where the first derivative is 0. Okay, what else can you tell me about the first derivative? Because there's two kinds of critical numbers, right?
It's undefined, it's.
Okay, yeah, it's undefined at 0 because look, my first derivative, if I write it this way, where are the red flags, right? Where are functions undefined? They're undefined for places that are not in the domain of parts of the function. Okay, but this is a cube root. The domain of cube root is everywhere, we're fine, right? No even roots, but I can't divide by 0. And so I would have to divide by 0 if I let x equal 0, right? So then we know we can also say okay, so we got 3 critical numbers then, right? Now what?
Take another derivative.
Okay, take another derivative. Okay, so moving down, another derivative. What's my second derivative going to look like? Second derivative.
Oh, this is.
What do we get?
Negative 2/3
Okay. Power rule, I'll bring that down front. I get negative 2/3 x to the
Negative 4/3.
negative 4/3, good, minus 2, okay? So if I write that as fractions, I'm getting negative 2 over 3x to the 4/3 minus 2. So where is the second derivative? Is it undefined anywhere?
Zero.
It's undefined at 0, but we don't care, right?
Yep.
Because what difference does it make? The first derivative is undefined there, so we don't really care. We're only looking for places in the second derivative where we get critical numbers where a tangent line exists, right? Those are the definition of of points of inflection, right? They have to be transitions of concavity from positive to negative through zero where a tangent line exists. Does a tangent line exist at zero?
No.
No, because the derivative is undefined. What could be going on at zero to make the derivative undefined? Could be a sharp corner, could be anything else. But there is no hole in our function, right?
It can't be an asymptote.
You're right, it's not an asymptote. Because our function doesn't have any. But what else could it be? Where would be places where, think derivative is slope, right?
Vertical tangent.
It could be a vertical tangent line too, couldn't it? Because a vertical line has no slope, right? So those are really the kinds of things we're looking for here. Okay? All right, so let's analyze this. Does this equal zero anywhere? Maybe, we gotta see, right? Does this equal zero anywhere? So we could set this equal to zero. When, if I just add the 2 to the other side, or add this to the other side, how about when 2 over 3x to the 4/3 equals negative 2. Okay. What do you think?
Multiplied by.
I could invert both sides.
Yeah.
I take the reciprocal of both sides. So I'm getting 3x to the 4/3 over 2 equals negative 1/2. Multiply both sides by 2/3. Right? So I'm getting x to the 4/3 equals negative 1/3. Talk to me about that. Where's that true?
I'm still amazed that you can just reciprocate.
Reciprocate.
What?
No, you can't. Doesn't that make sense? I mean,
Well, yeah, but.
right? If I have fractions on both sides that are equal to each other, then the reciprocals must also be equal to each other.
Blowing my mind.
So how would I solve for x?
That's a great question.
Okay,
So do we cube both sides?
'cause so we could do it in 2 steps if we wanted. We could cube both sides. Let's just watch this. And then we see if we can combine these in 1 step when we're done. So if I were to cube both sides, that's gonna give me x to the 4th equals negative 1/27.
Yes.
See a problem?
You're negative.
Yeah. You can't take an even root of a negative number and get a real result, right? We could get, imaginary results, complex numbers with imaginary parts. But we're looking for a real answer, aren't we, right? So we could have seen that right here. If I take both sides to the 3/4 power, if I'm taking both sides to the 3/4 power, is that an even or an odd power? It's an even power, right? And you can't take a negative number to an even power. So are we getting any critical numbers of the second derivative? We are not. All right, so then let's just gather up all this stuff here. Do we have this thing in?
Like, what'd you say? You said, what?
I think the picture in front of us.
Yeah.
First, they pretty split up. was at your house one time.
And see some out that we haven't.
Not really.
I mean, you were not there when you were there.
Oh.
No, he wasn't. I was there.
They're occupied. I said, just accept it.
Alright, they might be on my computer at home.
Oh.
And those Russian China book we read, we want our money now.
I didn't think I could. I thought it wasn't. Do you want from
Did you have some?
Okay, so here we go. Let's
We can do it.
let's make our table.
Or have 20 trillion. 20 trillion dollars.
Bring me my money.
By becoming United Countries, the state of great economies. I don't think those are the same
Oh,
thing.
my mom-
Okay, help me fill out the table, please. What am I doing here? What are some things I could add to my table?
Your domain.
And negative
Ah,
one
okay,
and
good. Domain.
Domain.
Jenny, you're getting ahead of yourself.
Critical numbers.
Zero.
Okay,
Zero,
0 was a
one.
critical number where what happened?
Who's undefined?
Undefined.
Okay, what other critical numbers did we have?
1 and -1.
Right?
Yeah, correct.
Okay. Now what?
Now we evaluate the second derivative at 1.
Okay, let's evaluate the second derivative at those places. So at 1, what's the value of the second derivative? Negative. So it's negative, so what's that tell us then?
That
It's
is,
negative.
that it's
Concave.
There's a horizontal tangent.
Horizontal tangent line.
There's
Good,
a
what it is.
maximum right there.
So it's a horizontal tangent line, and negative means it's a maximum. Okay? How about over here at -1? Still negative, isn't it? Right? In fact, second derivative's even, isn't it? Right? Because I've got a fourth power there. So this is also negative, so we end up with same thing. Okay?
We need to.
Test point.
is
Okay, maybe a test point. How come? What's unresolved here?
Is what do in between.
Okay.
Would that be just like a sharp corner in there?
Well, we don't know. We gotta find out, don't we? And we can't, so the first derivative test, we'd have to apply the first derivative test here, wouldn't we? Because the second derivative test is not gonna do us any good. Where the first derivative's undefined,
Do we need to take the limit of going to 0 from both sides?
No, we have to take a limit. We can just plug a value in. Like, what if I do negative 0.5 and positive 0.5? I'm looking at the sign of the first derivative here, right? Okay, so the sign of the first derivative is what?
Negative.
Positive.
Hey, Kimmy. Yep, will do. Okay, bye. Oh, you're supposed to go down. You are.
So where?
To the office. They didn't say why. So what about, what's the sign of the first derivative? Here's our first derivative. What's the sign of the first derivative at positive 1/2?
Yeah, stay with us, stay,